5. And we want to prove that the function f of x is equal to x cubed is uniformly continuous on the interval, open interval 0 to 2. So here I'm going to do the scratch work, and then I'm going to have you as students write the formal proof. If you're trying to remember, go back over the previous videos 3 and 4 to see how to do that. Okay, so we want to let epsilon be greater than 0. We choose a delta, but we don't know what that delta is yet. Then, but when we go back over our formal proof, we know what we will know what that is after we do the scratch work. Then let x and z be elements in the interval from 0 to 2, where we have f of x, the absolute value of the difference of f of x minus f of z is less than epsilon whenever the difference of x minus z is less than delta. So hopefully, you should be seeing a pattern here by now. So we need to find delta. We need to find a delta, okay, that we can substitute in for epsilon. So f of x, that is x cubed, and f of z, that's going to be z cubed, and we said that's less than epsilon. Okay, so when we factor the difference of two cubes, we get x minus z times x squared plus xz plus z squared. So that's the difference of two cubes. All right, and so that's equal to that. And so we can split that. X minus absolute value of x minus z times the absolute value of x squared plus xz plus z squared. Okay, and since we said the absolute value of x minus z is less than delta, right? That's what we said here. Then we can substitute delta in for that x minus z. So from there, since this is less than delta, this expression will be less than this one. That's why we have to change it to less than. And then this will be absolute value of x squared plus xz plus z squared. Okay, so from here, since x and z are elements in the interval from 0 to 2, then we can say that x is less than 2 and z is less than 2, because they have to be in order to be within that interval. Okay, so therefore we can say that we can substitute in 2 in for x and z. So, and that's all since x is less than 2 and z is less than 2, this expression is going to be less than the next step. So this will be 2 squared plus 2 times 2 plus 2 squared. Okay, so because x is less than 2, we can put that this expression is less, this expression is less than this one. And so from there, we can say that delta 2 squared is 4, 2 times 2 is 4, 2 squared is 4. So all of that is going to be the absolute value of 12. Well, the absolute value of 12 is 12, so this would be 12 delta. Since all of this is less than epsilon, right, we can say, all right, this is equal to epsilon. So if we divide 12 to both sides, we can say, all right, we can say that delta is epsilon over 12. So when we go to our formal proof, we can put an epsilon over 12 in here and then go through all these steps in the proof. And I'm going to have you finish that for your homework, because this is homework problem number 4. And so you can go ahead and finish that problem up.